Good evening, everybody. Welcome to test number 2 review with your host for Chem 170, me, Dr. White. Hi, everybody. All right, let me remind you, what you're going to see on the screen is in the lecture folder of D2L, cleverly named test number 2 review. And let's go through. Remember, there's no such thing as a dumb question. While I'm going through this, if you have any questions, feel free to ask. All right. Now, the first functional group you should know about, and by the way, I sent out an email the other day, the videos you should watch, the practice problems, and a previous review. I'll also post this sometime tonight or tomorrow morning on my YouTube channel. All right, alcohols, R group with OH, hydroxyl, alcohol. How do you name them? You find the longest chain or ring, and you name it as an alkane or cycloalkane. Drop the E at the end. For acyclic, you need a number. OL is there and then a number. Remember, functional groups always get the lowest number. For a ring, no number, when that's the only functional group in a ring, which is how it will be in my class. The hydroxyl group carbon in a ring is always number 1. Let's move this over here so I don't look like I'm looking over here. All right, you should know that a benzene ring with a hydroxyl group is called phenol. Now, common names. You name the R group attached to the hydroxyl group as the alkyl group it is, and then you add the word alcohol. Now, you should know rubbing alcohol is anywhere from, depending on which type you buy, 70 to 90% isopropyl alcohol, otherwise known as 2-propanol, and water. Speaking about that, you should know, if you go to your local gas station, you'll see a sign, at least here in Chicagoland, and I think most of the United States, that it says, I got a couple of hairs flying around here. I'll have to cut them off later. But anyways, you should know that gasoline contains up to 10% ethanol, which is an alcohol. Now, other things ethanol is in, beer, wine, and hard spirits. You know, the good stuff, like I like vodka and Canadian Club. My father loved Canadian Club. He wasn't a big vodka person like I am. All right, now let's look at a reaction. How do you make an alcohol? And this is the only reaction I can put on 2 different tests. Take a double bond, react it with acid and water. Remember, water is HOH, and you take and break the pi bond. One carbon gets H, the other gets the hydroxyl group OH, and it follows Markov-Nikov's rule. The carbon with the most hydrogens gets the hydrogen, and then we're talking about the hydrogens on carbon of the double bond, and the other carbon of the double bond gets the hydroxyl group. Important thing about test number 2, or any test or final in this class. 1, you should remember, how many bonds to carbon are there? 4. Oh, I gotta get this finger fixed. 4 bonds to carbon. 4. See, I can do it this hand. 4 bonds to carbon. 4. That's always going to be your friend. When you write down a structure, make sure a carbon has 4 bonds to it. If it has 3, if it has 5, it's going to be wrong. The other friend you should have on test 2 and all the other tests, do you break carbon-carbon single bonds? No. I'll say that again, slow motion. Do you break carbon-carbon single bonds? No, you don't. And so don't. Now, let's talk about reactions with alcohols. One of the more challenging this semester is called dehydration, meaning taking off water of alcohol. And you have a carbon with a hydroxyl group, OH, an adjacent carbon with a hydrogen, and you use sulfuric acid and heat, and you form a double bond. And this follows Zasev's rule. And Zasev's rule is you get the double bond that has the most carbon atoms directly bonded to the carbons of the double bond. And let's look at this. And the question would be, give the organic product or products for the following. And another thing you should always do, if you've been following my videos, when you look at an organic molecule, look for what's different. What's not a carbon-carbon single bond or a carbon or hydrogen atom should get your attention like this. Did that get your attention? Or like that. And we've noticed here's an oxygen with a hydrogen, OH group on a carbon. This is an alcohol. And on adjacent carbon, if we had a hydrogen, H2SO4, sulfuric acid, heat, get a double bond, and you get water, but you know I haven't been following inorganic stuff in my reactions. Yeah. Unless you're doing it in a plant, you don't need to. And when I mean a plant, what do you do with 4,000 pounds of water you make? Then you got to pay attention. My class, no. And it follows Zasev's rule. Oops, let me spell. All right, now here's the carbon here with the hydroxyl group. Adjacent carbon with a hydrogen, we have one here, A, and the other one, B. If I lose, let's go multicolor. And those are these carbons. If I lose the hydroxyl group, let's do this, A and B. If I lose the hydroxyl group and a hydrogen from A, I will form the following alkene, double bond. Remember, there are 4 bonds to carbon. Don't forget to put in your hydrogens. If we look at B, this carbon loses the hydrogen, you lose the hydrox group between the carbon with the hydrox group, and B, you'll form a double bond. And the question is, which one do you get? So how do we do that? Well, we count the carbon atoms directly bonded to the carbons of the double bond. In A, it's 1, 2, 3. 3 carbon atoms. In B, it's this one. It has to be directly bonded to the carbons of the double bond. These 2 carbons, you don't count because they're not directly bonded to the carbons of the double bond. So how many blue circles are carbons in B? 1. Oh, let me get back to. And now you have to use your high-level math skills. Isn't the math hard in my class? And which is the larger number, 3 or 1? And hopefully I'll pick 3. Therefore, the correct answer for this problem following Zasev's rule is A. And let's go back to the review. An easier reaction, you take an alcohol and react with HX. Remember, X can be chlorine, bromine, or iodine. You replace the hydroxyl group on the carbon with the hydroxyl group with a halogen. Now, if you had a double bond, you're not going to want to react it with along with the alcohol with the HX, because that will react with double bond. And someone, I don't know who did, came up with this reaction, which is you take an alcohol, react with thionyl chloride, SOCl2, you replace the hydroxyl group with a chlorine. Now, the nice thing about this is thionyl chloride, SOCl2, will not react with carbon-carbon double bonds. All right, you take a primary alcohol, and that is a carbon with one R group and an OH, and oxidize it. The symbol bracket O, close bracket, is for any oxidizing agent. And what you do is add the carbon with the hydroxyl group, lose this hydrogen, this one, and you form an aldehyde, which you learned later on what is an aldehyde. If you take a secondary alcohol, two R groups, remember R and R prime are just like X and Y in math, just a molecule with carbons and hydrogens, and you oxidize it, you'll do the same thing, lose a hydrogen here, hydrogen there, form a carbon-carbon double bond, just like you did up above, and you'll make a ketone. Now, next functional group, hopefully you've done the alcohol problem set. Next, thiols. That's the sulfur equivalent of an alcohol. Alcohol, you have ROH, replace the oxygen with a sulfur. And the two things you should know. One, they stink. Oh, boy, they stink. Think about skunk odor. They stink. The other thing is, and this is very important, due to the tragedy that happened about 1935 at the school in Texas, where I think about 150 students and teachers were killed, a lot of others were badly burned. Texas state government had a commission to make sure that you could smell natural gas when there's a leak, because methane has no odor. They came up with the concept of putting a thiol in there, T-butyl-thiol. And since then, the rest of the United States has that in our natural gas, what you cook with. Now, next I talked about ethers. Ethers is an oxygen with two R groups. And I only asked you to learn the common name. Name each R group as an alkyl group, then add the word ether at the end. Now, the only way, the best way, not the only way, the best way to make an ether is the Williamson ether synthesis. If you take an alkoxide, that's RO minus, Na plus, alkyl halide, R prime X, X can be chlorine, bromine, or iodide, you form an ether plus a salt. Now, the carbon with the halogen in R prime is the carbon this oxygen is bonded to in R prime and ether. The carbon with the halogen is the carbon that the oxygen, the ether, is bonded to. Let's take a look at that. As you know, I said there'd be a couple synthesis problems. So let's have you try one. I don't want to hog all the fun. And the question would be, what are the two what are the two starting materials to make that compound? Your turn. Nope. And when you're done, give me a thumbs up, because I don't have set for this meeting to do a poll to let me know when you're done. I see one person's done. When you're done, give me a thumbs up. We'll be patient, wait for everybody to finish. And everybody's finished. So what you need to do is, what product are we making? What's different? What's not carbon? What's not? Ooh, an oxygen. Carbon's here, carbon's here. This is an ether. Plus, we've got a salt. X can be chlorine, or in our case, it's bromine, or iodine. And how do you make an ether? The Williamson ether synthesis. An alkoxide plus an alkyl halide. So if I call this R and call this R prime, I would have this alkoxide. Now, which carbon in R prime has the oxygen? The end one. So that's the one the halogen will be bonded to, the end one. And what's the halogen? Bromine. But wait, what if I call this R prime and this R? And I can. So this carbon has the oxygen, which is the alkoxide, and R prime is a methyl group, and the halogen is still bromine. And which one of these is correct? They both are. Both will give this product. And that's how you do the Williamson ether synthesis. Now, next I talked about epoxides. I really talked about one epoxide, ethylene oxide. I'll never ask you on a test or to final what's the structure of ethylene oxide or what's the name of that. By the way, that's a common name. And Dr. White, has worked in the chemical industry with ethylene oxide at 2 separate companies. And the first time I did ethylene oxide reaction in a lab at one company, I'd never worked with it before, I got religion quick, because I was warned heavily, if you get oxygen in there and you heat it up, it will blow up and you'll die. And you will. And I didn't, as you can tell. All right, first reaction. You take an alcohol, react it with 1 mole or molecule of ethylene oxide, you make the following ether alcohol. If you take alcohol and react it with more than 1 mole, that's what N is 2 through whatever, you make this polyether alcohol. Now, it's important that the hydroxyl group is outside the bracket. Common mistake students make, they put it inside the bracket, and no such molecule ever has existed. And it's wrong, and I mark it wrong. And let's take a look at one of these. And it's your turn. What would be the product or products, organic products of the following reaction? 3 points each. And when you're done, give me a thumbs up. Like I said, when you're done, give me a thumbs up. You can do a thumbs down too. I don't care. All right. We look at this. What's different? What's not carbon? What's not? Oh, oxygen with a hydrogen and a carbon. That's an alcohol. And we've got N11, and this is ethylene oxide. I don't know if you saw in the video where I said I'll try and be good, and I was, because those of us who work with ethylene oxide just call it EO, but I don't do that for students because I don't like to use slang. And if you take an alcohol and react it with N moles of ethylene oxide, you form the following polyether alcohol. In this case, what's this? So I don't break carbon-carbon single bonds. That's my R group, bracket O, CH2, CH2. What's N? 11. And remember, the hydroxyl group, OH, is outside the bracket, and there are 4 bonds to carbon, so I can put in the rest of the hydrogens. And that's the product you get. And I work with a company, PPG Mazer, that made these type of, they're called the alcohol ethoxylates. And we did N as high as 25 and other different R groups. In fact, some of that goes into personal care products. All right, next. You saw the video, Dr. White was very happy. Aldehydes and ketones. They're some of my comfort functional groups. When I don't feel good, I'm blue, and I want to cheer myself up, I think about aldehydes and ketones. I did my PhD thesis on ketones and aldehydes, and also esters, and my first and last patents, US patents, dealt with aldehydes and ketones. All right, what's an aldehyde? It's a carbonyl, carbon double bond to oxygen with a hydrogen and R group. How do you name it? You find the longest chain that includes the carbon double bond to oxygen. Name it as an alkane. Drop the E, add Al. No number, because the carbon double bond to oxygen and aldehyde is always number 1, and you don't have to put that down because everybody knows that. Next, ketone, carbonyl with 2 R groups on it, R and R prime. They can be the same or different. Now, you cannot have an aldehyde in a ring, but you can have a ketone. And Dr. White and Mother Nature really love ketones. And how do you name them? You find the longest chain or ring with the carbon double bond to oxygen, which is called the carbonyl carbon. Do I have that later? Yes, I do. And you name it as an alkane or cycloalkane. Drop the E and add ONE. Now, for acyclic, you need a number. What carbon closest to the chain, end of the chain, has the carbon double bond to oxygen, carbonyl carbon? For a ring, you don't, because in all cases, a carbonyl carbon of a ketone in a ring is always number 1. Carbonyl carbons rock. Dr. White loves carbonyl carbons. They've been good to me. I've been good to them. All right. I asked you to learn 2 common names. First of all, the simplest aldehyde, and it turns out R can be an H in this case, is formaldehyde. Nobody ever calls that methanol. And I used that in my last patent, formaldehyde. I also talked about in the video you should watch the dangers of formaldehyde. And I worked for the company at that time, it was called Borden Chemical. Now it's called Hexion, which was the largest producer in the United States, if not the world, of formaldehyde. And we used it and we sold it. Next, the simplest ketone, the common name when R and R prime are methyl, is acetone. Nobody ever calls that 2-propanone. And acetone is one of the 2 molecules, I'll teach you later on the other one in the video, as nail polish remover. So you should know acetone, nail polish remover, and it's a ketone. Now, one of the most important things to me personally, I think to any organic chemist should be the carbonyl group. That's a carbon atom double bond to an oxygen atom. It's in a ketone, it's in an aldehyde, and you'll see it's in other functional groups. It is not a functional group, but it's an important group, probably in my mind, the most important in all of organic chemistry. And you should know how to draw the carbonyl group. You see it on the screen, and you should know how to describe with words and what is a carbonyl group. It's a carbon atom or just carbon double bonded to oxygen or oxygen atom. All right, how do you make ketones and aldehydes? Well, we already did this. Take a primary alcohol, oxidize it, you get an aldehyde. Take a secondary alcohol, oxidize it, you get a ketone. Now, this is a neat reaction, and that's to make aromatic ketones. Excuse me, time for some water. Now, here, you take a benzene ring, react, this is called an acid chloride, and aluminum trichloride, you'll make a aromatic ketone. And aromatic ketones, one of the big uses is a sunscreen to protect you from getting skin cancer. It absorbs the UV radiation. And it's also used as an initiator. You know, the nail polish you shine the light on to harden, we call that cure, does that. All right. Now, the next 4 reactions I will never use in a synthesis problem because they're a little tricky. The first one, you take an aldehyde or ketone, which is R prime, can be hydrogen, it's an aldehyde, R prime carbons, ketone, reacted with an alcohol and acid catalyst, H plus. Keep your eye on the carbonyl carbon. What's attached to it, R prime and R double prime are still there. This opens up to OH, and the part of the alcohol, OR, is attached to that same carbon, hemiacetal. You take an, oh, I don't have it here. Shame on Dr. White. If you take an aldehyde or ketone and react it now with 2 moles of an alcohol and acid catalyst, what's attached to the carbonyl carbon is still there, R prime or H and R double prime, and, excuse me, you get an acetal, 2 OR groups. Now, there's a special case that my advisor, my PhD advisor, who I will always be forever grateful, because under his leadership and being part of his research group and having been my advisor, I became really a synthetic organic chemist. PhD is like being a plumber's apprentice. When you're a grad student, you work for one till you can be a plumber, organic chemist. All right, now my advisor's advisor, Dr. Stork, came up with the following special case. If you take an aldehyde or ketone, react that this is ethylene glycol, which has 2 hydroxyl groups, 2 alcohols in it, H plus, it's the same as this. Each R group, the CH2, will be bonded to the carbon. What's bonded here, R prime or H and R double prime still there, and you have this molecule. Now, students, for whatever reason, forget to put that bond between the 2 CH2 groups. I don't know why they forget to do that. If you do, I mark it wrong. Don't. Don't. Oh, that was good. All right. Now, that's a way of protecting a ketone or aldehyde if you're going to react it with something that would, another functional group in a molecule that would react with a ketone aldehyde, don't want it. Now, Once you have a hemiacetal, oh, I should mention, these two reactions right here, if they didn't happen and Mother Nature uses them, we wouldn't have any carbohydrates in our life. And you'll learn later in the semester about carbohydrates, how these two reactions help form carbohydrates. Like the good things, pizza crust, French fries, baked potatoes, rice, all the good things in life. All right. Now, once you have a hemiacetal, acid and water, that's H plus, we'll break it down, reverse it, and you get back the aldehyde or ketone plus the alcohol you would have used to make that hemiacetal or hemiketal. Now, if you have an acetal or ketal and you react it with acid and water, you'll get back again the aldehyde or ketone plus the alcohol. Now, I don't ask you to balance equations. We don't unless you have to. In this case, I put the two there because years ago I had these twin sisters. They were pretty identical, other than their personality. And one had a streak of blonde in her hair, so I could tell the two apart. Personality, I finally learned one was more dominant than the other. That's always true in twins. Throughout the years, I've had, I think, 5 sets of twins in my class, but these two were, whoa. And if you didn't put down the two there and balance equations, they got really upset. I don't like upset students. That's why there's a 2, but you don't have to. That's why it's little in brackets. Now, these two reactions, that's how your stomach breaks down carbohydrates. And I'll teach you that later on, because the H plus in your stomach is hydrochloric acid. All right, important reaction by one of my heroes in organic chemistry, the great organic chemist, Dr. Victor Grignard, who got the Nobel Prize for this in the next reaction. You take an alkyl halide, react it with magnesium, you get a Grignard reagent. Remember, it's RMGX, not RXMG. You get the X and MG wrong, I mark it wrong. Now, the reaction that I've done and used in research is the following. Take an aldehyde or ketone, first step react it with the Grignard reagent, second step acid and water. You do something very special. You make a carbon-carbon single bond and you make this alcohol. And remember, I forgot to mention here, X in the Grignard reagent can be chlorine, bromine, or iodine. This reaction right here, the Grignard reaction with a ketone or aldehyde, I'll never put a synthesis problem on a test. But I want you to have some fun, so let's have some fun. And here's something for you to have fun. Give the organic product or products are the following. 3 points each. And give me a thumbs up when you're done. Aren't you glad I share the fun? Take your time. Thank you for letting me know you're almost done. I'll wait for everybody to finish. Or if you want me to go ahead, give me a thumbs up and I'll go ahead. If you haven't finished. Well, I know Megan's finished. All right, everybody's finished. Isn't it nice? Dr. White's patient gives everybody time to finish. We'll look at what are we starting with? What's different? Ooh, an oxygen double bond to carbon here, carbons here and here. This is a ketone. It just so happens R and R prime are connected together in the ring, but it could have been an aldehyde. And we look here, what's different? Carbon, carbon, carbon. Ooh, magnesium halide. That's a Grignard reagent. Second step, acid and water. Remember, X can be chlorine, bromine, or, excuse me, in our case, iodine. And keep your eye on the carbonyl carbon. That's where all the fun is. What's attached to it, our prime and our double prime, or hydrogen for our prime, is still there. This opens up to an alcohol, and the R triple prime, the carbon with the MgX, is now bonded to this carbon right here. And you form that special carbon-carbon single bond. So here's our carbon right here, this carbon. This one in the ring. We don't break carbon-carbon single bonds. And that's this carbon right here, is this carbon right here. It'll have an OH. And what's our R group, our triple prime? And the carbon with the Grignard is the carbon that's going to be bonded to the carbonyl carbon here. And that's the product. Now, if you put the hydroxyl group here and the N-propyl group here, have them switch, that's fine. Did I tell you I'm this close to the person who grades the test? Me. All right, let's get back to, now, remember, carbonyl has a pi bond and a sigma bond. And you learn from double bonds, carbon-carbon double bonds, hydrogen and catalyst, you can break it. And in this case, each atom of the carbonyl gets a hydrogen, and this is a nice way of making alcohols, which I've done. Now, hydrogen and catalyst, you know, can also react with a carbon-carbon double bond. And H.C. Brown of Purdue came up at the end of World War II. He did this, and later on he got the Nobel Prize for it. If you take lithium aluminum hydride, second step acid and water, it's the same thing. You break the pi bond, and each atom of the carbonyl gets a hydrogen. Now, the nice thing about lithium aluminum hydride, which I have worked with in the lab when I was doing my PhD work, is it will not attack carbon-carbon double bonds like hydrogen will. And finally, the last reaction here is the aldol condensation. Now, if you look at the video, I was having a good time because you make an enolate anion, and my PhD thesis dealt with a very, very specialized enolate anion that most organic chemists don't even know about. That's the cross-conjugated, kinetically favored enolate anion. But here, base enolate anion, the carbon, alpha carbon attached to the carbonyl, has acidic hydrogens. You pull it off, it attacks this carbonyl, and you form a carbon-carbon single bond. Again, something very special, very rare. And I'm sure I mentioned in the video, Dr. White, I know about 400 general reactions. So I know all of them in organic chemistry? No, but I know a lot of them because I've worked with them over the years. I've been doing this for more than a few months, if you haven't figured it out. And this is a very nice reaction. Well, let's have some fun with this. And my gift to you is, and I don't have to, I'll write the aldehyde twice. If I were with my colleagues who have PhD in organic chemistry, I just write one. I wouldn't even balance it, sodium hydroxide and water, and they would know it's a aldol condensation if they knew their organic chemistry, which over the years, most of my colleagues did. Your turn. What would be the product or product for a following reaction? 3 points each. And when you're done, give me a thumbs up. And this reaction, because it is more challenging, I will never give a synthesis problem, both on test 2 or the final. That's not fair. I can do it, but you would have trouble. Don't forget, you don't have a PhD like I do. All right, everybody's done. My turn. If we look, what's different? Ooh, oxygen, double bond to carbon with hydrogen and R group, same molecule. This is an aldol condensation. Well, Marion, we'll find out how you did. That's why we practice. Well, general reaction. And once in a while, I have to look on the test. I forget to put water, but you still, I think I did that. Well, you got an aldehyde reacting with itself. The alpha carbon has acidic hydrogens. You pull one off, it attacks that. You pull one off, so instead of CH2, it's CH. And it's from the alpha carbon to the carbonyl carbon of the other aldehyde, and it opens it up to an alcohol. What's attached to it is still attached to it. What's our CH3? Now, I can also just say, I know here's my alpha carbon. This will attack the carbonyl carbon. Do you notice how violent organic chemists are? We actually say it attacks it. Pull off one hydrogen from the first aldehyde. It attacks the carbonyl carbon of the second. And what's attached to it is still attached to it. And Marion, did you get it right? If you look at, if you forgot the OH here, did you only have 3 bonds to this carbon? And therefore, and I'll do another one, remember, whenever you're changing something, look at that carbon and make sure there are 4 bonds to it. If you don't have 4 bonds, I gotta get this finger fixed, 4 bonds to carbon, it's wrong. All right, by popular demand, let's do another one. Oh, let's have some big fun. And here you go. Here's another one. Your turn to have fun. And when you're done, give me a thumbs up. Thank you, Megan. I should say, thank you, Megan's iPad. Boy, I didn't know I had an iPad in my class. Thank you, Marion. You got to experience Dr. White's bad humor firsthand, live. All right, let's take a look at this. What's different in this molecule? Oxygen, double bond to carbon with hydrogen. Carbon's here. Aldehyde. Second one, same thing, same aldehyde. Sodium hydroxide and water. It's the allyl condensation. The alpha carbon has acidic protons. Pull one off, form an enolate anion that attacks the other carbonyl carbon. So I'll pull one off. Attacks the other carbonyl carbon right here, opens it up to an alcohol. What was attached to it is still attached to it. And what's our? A cyclohexane ring. And again, here's my alpha carbon. Pull off a hydrogen. This attacks the carbonyl carbon. Notice I have one less hydrogen on that carbon, the alpha carbon. And the carbonyl carbon opens up to an alcohol. What was attached to it, CH2. And my ring, and that's the product you get. And hopefully that second one helped you. Yay for Marion. Doesn't that feel good? You can do what most people on this planet can't, organic chemistry. Think about it, on not just in Elgin or Northern Illinois, but the whole planet. All right, let's go back to the review. Oh no, I finished it, but I'm not done yet. let's have some fun before we call it an evening. Let's play that fun game, circle and name the functional group or groups, 2 points each. That's that fun game where you circle and name the functional group, not the whole molecule. Let's try this one. And let's do 2 of them. And here you go. Here's 2 of them for you to have fun with. This nice smoky, I guess, outside. Someone just told me earlier today, but this nice Tuesday evening. And again, the way you play it is circle and name the functional group, 2 points each. When you're done, give me a thumbs up. Remember, look for something different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. And when you're done, give me a thumbs up. I just remembered I forgot to do something. I was writing myself a note. Thank you, Megan. And we'll wait for everybody to finish. Everybody's finished. My turn. We look at A. Ooh, oxygen with a hydrogen and a carbon. You don't have to do this, but I'll write it down like this. What is this? An alcohol. Oh, wait, here's another oxygen. To double bond a carbon with a hydrogen and carbons. And again, you don't have to write what I'm writing now, but what is this? It's an aldehyde. Ooh, this is fun. Circle and name the functional group or groups, 2 points each. Now, if we look in B, ooh, oxygen here, carbons here and here. Again, you don't have to do this, but I will. What is this? It's an ether. Ooh, oxygen, hydrogen, carbon. Again, you don't have to do the ROH, but circle it, and that's an alcohol. Oh, wait, we're not done. Up here, oxygen, double bond to carbon. Carbon's here and here in the ring. And what is this? This is a ketone. Are we, oh no, another oxygen, double bond to carbon with a hydrogen and carbons. And what is this? I wrote this, you don't have to write this, but this is an aldehyde. And that's how you play that fun game. Circle and name the functional group or groups, 2 points each. I see I have a question. Did I spell aldehyde wrong? Oh, you got it right. All right. Remember, on test 2, check any carbon you've changed. Make sure all your carbons and structures, I'm going to have to get that fixed one of these years, have 4 bonds to it, my college ring, 4 bonds to carbon. I don't know if you can see this, but you see the year? That's when I got my bachelor's degree, 1972. Oh, I shouldn't have showed it to you. All right, remember, 4 bonds to carbon. Next. It was, Megan. Anyways, 4 bonds to carbon. Also, do you break carbon-carbon single bonds? No. And finally, I don't push this, but look for what's different. Well, I do actually. Look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like this. Hopefully that got your attention. Now, don't forget, if you have any questions, tomorrow night, Wednesday night, I'll have my office hour from 7 to 8. Stop by, say hello, or ask your questions. I'll help anybody who needs help. On Thursday morning, about 8 a.m., I will send out a password for the password protected PDF file for test 2 that you will download from the assignment area D2L. You'll have until Friday, 4 p.m. to take test number 2, upload your answers as a single PDF file like you did in test 1, and by Sunday, 1 p.m. or earlier, I will have your test scores posted in D2L. I'll send out an email to that. And by the same time, I'll send out to each of you an individual email with your points for every answer you put on test number 2. Oh, excuse me. Next Monday, I will go through test number 2. I'm not sure what time because I got my office hour. I think probably 8 to 9 I'll do it. And I'll videotape it and I'll post it as a private video and I'll send out the URL. With that, I'm done. If any of you have questions, hang around. I will. And with that, I can say, Gehen gesund. Remember, that's Yiddish for going out. I started doing that at the beginning of the pandemic. My grandmother, my mother's mother, Grandma Greenman, what a great lady she was. Probably one of the finest people I've ever met in my life. Would always say when we left her place, she'd say, Gehen gesund. And that means go in health. So I'll say, Gehen gesund. Bye now. I stole that from Granny to Beverly Hillbillies. Bye.